Hi everyone, Dennis here. In this video, we are going to discuss GCE O-Level Additional Mathematics October-November 2022 paper 2. The subject code is 4049. This video is brought to you by Ace with Dennis. Now, learning can be smart, not hard. Also, don't forget to subscribe and press the bell notification button to stop missing out free lessons from me. Question 2. It is given that fx equals x cubed plus ax squared minus 3x plus b, where a and b are constants, has a factors of x plus 2, and leave a remainder of 30 when divided by x minus 3. A. Find the values of a and b. 4 marks. So for this question, we have to find two unknowns, a and b. So in order to find the values of a and b, we have to solve simultaneous equation, which means we need to form two equations. So the first equation can be formed from the information given where this equation has a factor of x plus 2. So by factor theorem, f negative 2 equals 0 because x plus 2 is a factor. Then we substitute the fx where the x is negative 2. Then the equation becomes negative 2 cubed plus a times negative 2 square minus 3 times negative 2 plus b equals 0. Then expand the indices. We have negative 8 plus 4a plus 6 plus b equals 0. So 4a plus b equals 2. Next, to form the second equation, we use the second information where it states that it leaves a remainder of 30 when divided by x minus 3. Hence, by remainder theorem, f3 equals 30, which means 3 cubed plus a times 3 square minus 3 times 3 plus b equals 30. Expand, we have 27 plus 9a minus 9 plus b equals 30. Simplify, we have 9a plus b equals 12. So I label 4a plus b equals 2 as the first equation and 9a plus b equals 12 as second equation. Then I say that equation number 2 minus equation number 1, then I will have 5a equals 10. Hence a equals 2. Now I want to find b. Substitute a equals to 2 into the first equation. We have 4 times 2 plus b equals 2. Hence b equals to negative 6. B. Using these values of a and b, vectorize fx completely into 3 linear vectors using sets where necessary. 3 marks. So now let's update the equation using the values of a and b which we have found in part A. So fx equals x cubed plus 2x squared minus 3x minus 6. Then we can do the long division to find the quadratic factor. So this is the dividend x cubed plus 2x squared minus 3x minus 6, and the divisor is x plus 2. So x squared times x plus 2, we get x cubed plus 2x squared. So the dividend minus x cubed plus 2x squared, we have 0. Next, I copy down minus 3x minus 6 and negative 3 times x plus 2, we get negative 3x minus 6. So the negative 3x minus 6 minus negative 3x minus 6, we get 0. So we should expect that the remainder is 0 because x plus 2 is a factor. Okay, so now we can update the equation. It becomes fx equals x plus 2 times x squared minus 3. So this x squared minus 3 is the quotient that we get from the long division. So this x squared minus 3, we can further factorize, becomes x minus 3 times x plus 3. So after factorizing this equation completely, we have fx equals x plus 2 times x minus 3 times x plus 3. Question 3. A. Prove the identity tangent 2 theta times 2 cosine theta minus secant theta equals 2 sine theta. 4 marks. So to prove this identity, I will start from the left hand side, which is tangent 2 theta times 2 cosine theta minus secant theta. So the very first thing I want to do is I want to change the tangent and the secant into sine and cosine only. Okay, so tangent 2 theta will be sine 2 theta over cosine 2 theta, while secant theta will be 1 over cosine theta. So 2 cosine theta will remain the same. Okay, next step, for this sine 2 theta and cosine 2 theta, I will use double angle formula. Sine 2 theta becomes 2 sine theta cosine theta, and cosine 2 theta is 2 cosine square theta minus 1. Okay, if you cannot remember the formula, you can always refer to the formula list. And inside the bracket here, I want to make these two terms to have the common denominator of cosine theta. Hence, this cosine 2 cosine theta becomes 2 cosine square theta, then minus 1 here. Okay, when it comes to this step, I can start to simplify where 2 cosine square theta minus 1 can cancel out, and cosine theta can cancel out here. So at the end, I will get 2 sine theta, hence proven. Next, B, hence solve the equation. Tangent 2 theta times 2 cosine theta minus secant theta equals half secant theta. For the range of theta from 0 degrees to 360 degrees, 4 marks. Alright, so let's copy down the equation given. Tangent 2 theta times 2 cosine theta minus secant theta equals half secant theta. Then we change this whole thing, right, to be 2 sine theta because it's already proven these two are equal. So 2 sine theta and the right hand side secant theta I change to 1 over cosine theta. So it becomes 1 over 2 cosine theta here. Next, I will move cosine theta to the left hand side. So the left side becomes 2 sine theta cosine theta equals half. And we know that 2 sine theta cosine theta is sine 2 theta. So sine 2 theta equals to half. So from here, now we can start to solve this equation. First, we find the best angle, which is the inverse of sine, half, and we get 30 degrees. Next, we check the range, given the range of theta is from 0 to 360 inclusive. So for 2 theta will be from 0 degrees to 720 degrees. Then the 2 theta will be, since it is a positive sign, that means it is in the first and the second quadrant. So the 2 theta will be 30 degrees and 150 degrees, right? So this is from the first quadrant and this is from the second quadrant. So the next two, right, this 390 degrees comes from 30 degrees plus 360, which is another circle. I get 390 degrees. 150 degrees plus 360 degrees, we have 510 degrees. Okay, make sure that these two values are still within the range from 0 to 720 degrees. Okay, now next, theta will be just divide by 2 for each values here. So 30 divided by 2 is 15, 150 degrees divided by 2 is 75 degrees, and so on. So 190 degrees and 205 degrees. So this will be the answer for this question. Question 4. Given this diagram. The diagram shows a closed food container design in the shape of a cuboid. The rectangular base has dimensions of x centimeters and 3x centimeters. The height of the container is h centimeters. The volume of the container is 2000 centimeters cubed. A. Show that the total surface area of the 6 faces of the container is 6x squared plus 16,000 over 3x. 4 marks. Okay, so now before we want to find the total surface area, we will start from the volume first. So the volume for a cuboid will be 3x times x times h. And given the volume of this container is 2000, so this equation will be 2000 equals 3x squared h. Then we make h the subject, h equals 2000 over 3x squared. Okay, you might be wondering why we want to do these steps, because as you can see that the total surface area that we need to show has no h, but in the diagram we have a h here. So we have to substitute the h in terms of the x. So this is where we can substitute the h in terms of the x here. Now we can start to answer the question here. Total surface area, let's label it as an A here, right? So we start from the top and the bottom faces here. So they are the same rectangle, which is 3x times x. Then I multiply by 2 because we have two faces with the same rectangle. Then plus with the front and the back face, right, is also another identical rectangle where this length is 3x, this length is h. So it's 3x times h times 2. Next, we go to the left and the right faces, which are also identical, right, where the area of one side here is x times h, so xh, then times 2 here. Alright, next step, we'll get 6. We simplify everything, right? So 2 times 3x times x, we get 6x squared. Next, 2 times 3x times h, we get 6xh. And 2 times x times h, we get 2xh. Alright, next one, we can simplify these two terms, becomes 8xh. And then after that, we substitute this h to be 2000 over 3x squared here. Alright, the rest still the same, just copy down. Then simplify further, we'll get 6x squared plus 16,000 over 3x, hence shown. Okay, now move on to B. Given that x can vary, find the value of x for which the total surface area is stationary. So 4 marks here. When I see the word stationary, I know that I need to differentiate this surface area and then let it to be 0. Okay, so for this case, I will differentiate the a, right, in terms of x. So first, given we already proven a equals to 6x squared plus 16,000 over 3x, then we can change this term in terms in indices form so that we can differentiate it easily. So now dA over dx will be 12x. Okay, so the 2 bring down, power bring down, 6 times 2 is 12, then power minus 1, 12x. Similarly, 16,000 by 3 times negative 1, we have minus 16,000 by 3. And then this power minus 1, negative 1 minus 1 is negative 2. So x to the power of negative 2. So simplify, we get 12x minus 16,000 over 3x squared. So since it is stationary, then dA over dx is 0. That means 12x minus 16,000 divided by 3x squared equals 0. 12x equals 16,000 over 3x squared. So cross multiply or bring this 12 to the bottom, x squared to the left hand side. We have x cubed equals 16,000 divided by 3 times 12. So x will be cube root of 16,000 divided by 3 times 12. Then press calculator, we get the value of x is 7.63, rounded up to 3 significant figures. C. Determine whether this value of x gives a maximum or minimum value for the total surface area of the container. 2 marks. Alright, so to prove if it is a maximum or minimum value, there are 2 methods we can use. Either we use the tabular method or we use a second derivative method. So I prefer to use second derivative methods because it's much easier. So we start from dA over dx, which we have obtained in part B. It is equals to 12x minus 16,000 over 3, x to the power of negative 2. So we differentiate second time, we have d square a over dx squared that equals 12 minus negative 2 times 16,000 over 3, then x to the power of negative 3. Okay, so remember the power bring down, then we have negative 2 in front here, and power minus 1, negative 2 minus 1, we get negative 3 here. So the rest we just copy down as the same. For this case, 12x, when differentiate we get 12. Then we simplify further, we get d square a over dx squared equals 12 plus 32,000 over 3x cubed. So next, we substitute x equals to 7.63, which we get from part B, right? We found that from here, this part, 32,000 divided by 3 times 7.63 cubed, right? This whole thing, I don't have to really calculate the exact value. I know it is positive, okay? Because this value is positive, when the cube you get a positive value, then everything is positive. Hence, if we get a positive value, that means the 12 also a positive plus a positive value. This d squared a over dx squared will be positive. Therefore, we can make a conclusion that x equals 7.63 gives a minimum value for the total surface area of the container. Question 5. A calculator must not be used in this question. A. Show that tangent 75 degrees equals 2 plus 3. 4 marks. Okay, remember you cannot use calculator in this question. So we cannot just press calculator tangent 75 degrees and see what's the value. So what we can do is we can break down this 75 degrees into 45 degrees plus 30 degrees. Alright, so then we can use addition formula to change this into this, which is tangent 45 degrees plus tangent 30 degrees over 1 minus tangent 45 degrees times tangent 30 degrees. Okay, so why we want to choose 45 degrees and 30 degrees? Because we know tangent 45 degrees is 1 and tangent 30 degrees is sub 3 over 3. So they are special angles here. So substitute into this expression, right? We have 1 plus sub 3 over 3 over 1 minus 1 sub 3 over 3. Okay, then from here we can multiply 3 over 3 here so that we can eliminate the fraction here over 3. So we have 3 plus sub 3 over 3 minus sub 3. And we see that we have a sub at the denominator. All we can do is we can rationalize it. Right, so how to rationalize? We multiply 3 plus sub 3 over 3 plus sub 3 here for the top and the bottom. Then we expand. So this multiply with this one, we have 9 plus 6 sub 3 plus 3 over 9 minus 3. So simplify further, we have 12 plus 6 sub 3 over 6. Then break it into two terms. We have 12 divided by 6, we get 2. 6 divided by 6 is 1. So we get 2 plus sub 3. So this is the same as the one that we need to show. B. Using the result from part A to find an expression for secant square 75 degrees in the form a plus b sub 3 where a and b are integers. Alright, so secant square 75 degrees, it is 1 plus tangent square 75 degrees because we are using basic identities formula. Okay, and we know that tangent 75 degrees is 2 plus sub 3. So square the whole thing. Expand here, we have 1 plus 4 sub 3 plus 3. Then simplify, we get 8 plus 4 sub 3. So it is in the form of a plus b sub 3. C. Hence express cosine square 75 degrees in the form c plus d sub 3 where c and d are integers, 2 marks. So we can use the answer from part B to answer this question. So cosine square 75 degrees, it is 1 over secant square 75 degrees. So we know secant square 75 degrees is 8 plus 4 sub 3. Then we rationalize this fraction here by multiplying 8 minus 4 sub 3 over 8 minus 4 sub 3, which we get 8 minus 4 sub 3 over 64 minus 16 times 3. Simplify, we have 8 minus 4 sub 3 over 16, then break it into two terms. It will be 8 divided by 16 is half, 4 divided by 16 is 1 over 4. So answer, half minus 1 quarter sub 3. Question 6. A. Solve the equation 2 to the power x plus 4 to the power x minus 1 equals 15. 5 marks. So from the given equation, 2 to the power x plus 4 to the power x minus 1 equals 15. So the first thing we can do is we can break this index into this form. So 4 to the power x times 4 to the power negative 1. Okay, the rest we just copy down. After that, for this part, 4 to the power x, the 4 is 2 square. Then we can write bracket 2 square to the power x. 4 negative 1 is over 4 here. Right, the rest again we copy down. So for this one, 2 square x, we can rewrite it as 2 to the power x, then outside the bracket square. Okay, why we want to do this? Because we want to form the quadratic equation so that you can solve it easily. So how we can do that? We just let y to be 2 to the power of x. Then we update the equation. It becomes y plus y squared over 4 equals 15. Okay, now from here I can see there's a fraction here which is denominator as 4. I want to eliminate this denominator. What I do is I multiply by 4 for both sides. I will have 4y plus y squared equals 60. Now we rearrange this equation. We have y squared plus 4y minus 60 equals 0. Okay, now this is in the quadratic equation form. We can start to solve this equation. We factorize it, we have y minus 6 times y plus 10 equals 0, which means y equals to 6 or y equals to negative 10. So we substitute back the y to be 2 to the power x that equals to 6, or 2 to the power x equals negative 10. So 2 to the power x equals negative 10, we need to reject it because we wouldn't get a negative answer. For the left hand side, we can log both sides. Log 2 to the power x equals log 6. Then we can bring down the power, x log 2 equals log 6, which means x equals log 6 over log 2. Then press calculator, we have 2.58 rounded up to 3 single figures. So this is the answer for part A. Then for B, the curve y equals 5 minus e to the power of 2x intersects the x-axis at A and y-axis at B. 1. Find the coordinates of A and B in logarithmic form where appropriate. 2 marks. Okay, so as you can see, this curve intersects x-axis at A, y-axis at B. So what does it mean here? So when it intersects at x-axis, that means the y coordinate is 0. When it intersects at y-axis, that means the x coordinate is 0. So to find the coordinates of A, we know the y coordinate is 0, then we let y to be 0, substitute into this equation, then we get 0 equals 5 minus e to the power of 2x. Then we solve this equation. E to the power of 2x equals 5, so which means 2x equals ln 5, x will be half ln 5 or ln 5. Hence, the coordinates of A will be ln 5, 0. So similarly, for B, since it intersects y-axis, that means the x coordinate to be 0. So x equal to 0. Substitute into this equation, y equals 5 minus e to the power 2 times 0. Again, remember, e to the power 2 times 0 is not 0, but is 1. So 5 minus 1, which means the answer is 4. The coordinates of B will be 0, 4. 2. Find the gradient of the curve at A. 2 marks. Okay, so when I see the word gradient for the curve, I know I need to differentiate because gradient of a curve is dy over dx. So given y equals 5 minus e to the power of 2x, then dy over dx will be negative 2 e to the power of 2x. So now the x value for point A is ln 5. That means when x is ln 5, then dy over dx will be negative 2 times e to the power of 2 ln 5, which means it's negative 2 e ln 5, or negative 2 times 5, and the value is negative 10. Hence, the gradient at point A is negative 10. Question 7. Given this diagram, 2 countries were separated by a border that runs from west to east. Okay, from west to east, this line is the border. Village A and B lie on the border. So this is village A, this is village B. A helicopter flies 30 kilometers from village A to a village C. So from village A to village C here. Angle BAC is theta degrees. So BAC, this angle is theta degrees. The helicopter then travels 20 kilometers to a village D at an angle 90 degrees to AC as shown. So 90 degrees, 20 kilometers to village D. You can assume that the helicopter always flies at the same height. A. Show that the shortest distance of village D from the border is 30 sine theta minus 20 cosine theta kilometers. 3 marks. So this will be the shortest distance which is perpendicular to the border. But before that, I would draw the perpendicular distance from C to the border first, and then I will form a right angle triangle here. So I will label this length as H1. Okay, from this triangle, I can say that sine theta equals H1 over 30. Okay, opposite side over hypotenuse, which means H1 will be 30 sine theta. Okay, so as you see, it is same as this one. Next, this is the distance that we want to find. The perpendicular distance from D to the border will be the shortest distance. So I label this as H2. And also, I draw a line from here. Then this line is parallel with this line. In other words, this angle will be same with this angle because this is corresponding angles. After that, this angle will be 90 minus theta. Now from here, right, I will look at this right angle triangle. So if this 90 degrees, this is theta, then this angle will be 90 degrees minus theta. After that, this is a right angle triangle. So if this is 90 degrees minus theta, this 90 degrees, that means this angle is theta. Then from here, I will look at this right angle triangle and I label this length as H3. So H3, based on this right angle triangle, I can say that cosine theta equals H3 over 20, okay, because cosine is adjacent over hypotenuse. So H3 over 20, which means H3 is 20 cosine theta. Alright, then from this diagram, we can say that H2 equals H1 minus H3. Then we substitute all the values here. H1 is 30 sine theta, H3 is 20 cosine theta, hence shown. Then B, express 30 sine theta minus 20 cosine theta in the form r sine theta minus alpha, where r is greater than 0 and the range of the alpha is from 0 degrees to 90 degrees for marks. Okay, so very simple. We just apply the r formula. So to find r, it will be square root of 30 degrees, 30 square plus 20 square. So this comes from 30 and 20 here. Then simplify, we have square root of 1300. Then change it into the short form is 10 sub 13. Then we find the alpha, which is inverse of tangent 20 over 30. So we will get 33.7 degrees. Then we can change it into the r formula. 30 sine theta minus 20 cosine theta will be 10 sub 13 sine theta minus 33.7 degrees. C. Find the value of theta if village D is 10 kilometers from the border. 2 marks. So we know that H2 equals 10 sub 13 sine theta minus 33.7 degrees. So the H2 is 10. Equation becomes 10 equals 10 sub 13 sine theta minus 33.7 degrees. Then we can solve this equation to get the value of the theta. So from here, sine theta minus 33.7 degrees equals 1 over sub 13. So theta minus 33.7 degrees is inverse of sine 1 over sub 13, which is theta equals 16.1 degrees plus 33.7 degrees, and the value is 49.8 degrees. Question 8. The equation of a curve is y equals bracket x minus 3 times square root of 2x plus 1. A. Show that dy over dx equals 3x minus 2 over sub 2x plus 1. 4 marks. So given the equation y equals x minus 3 times square root of 2x plus 1, we can change this equation into indices form so that we can differentiate it easily. So it becomes x minus 3 times 2x plus 1 to the power of half. Then, using product rule, dy over dx equals x minus 3 times half bracket 2x plus 1 to the power of negative half times 2. Then plus 2x plus 1 to the power of half times 1. So simplify, we have x minus 3 over 2x plus 1 plus square root of 2x plus 1. Then we have to combine these two terms into one fraction. So it becomes x minus 3 plus 2x plus 1 over square root of 2x plus 1. Simplify, we will get 3x minus 2 over square root of 2x plus 1, hence shown. So B, a particle moves along the curve in such a way that the x-coordinate is increasing at a constant rate of 0.15 units per second. Find the rate of change of y-coordinate at the point where x equals 4. 2 marks. So we want to find the rate of change of y-coordinate, hence we can write as dy over dt. Then we apply the chain rule. So we start with dy and end with dt. So if dy over something times something over dt. So what will be these two? So these two should be the same because of the chain rule, right? So it will be dx, and this is also dx. Okay, because we know dy over dx. And we also know the x over dt, which is given. Right, so dy over dx is 3x minus 2 over square root of 2x plus 1. Dx over dt is given 0.15. Next, when x equals to 4, then dy over dt will be, substitute the x to be 4, 3 times 4 minus 2 over square root of 2 times 4 plus 1, then times 0.15. Then calculate everything here, we will have 0.5 units per second. So this is the rate of change of y coordinate where the x equals to 4. C. Use the result from part A to evaluate integration from 0 to 4 x over square root of 2x plus 1 dx. 4 marks. Okay, so this is differentiation the integration case. So from part A, 3x minus 2 over square root of 2x plus 1 equals the differentiation over dx of x minus 3 square root of 2x plus 1. So from this fraction, we can break it into two fractions, which is 3x over square root of 2x plus 1 minus 2 over square root of 2x plus 1. So why I want to do this? Because as we can see, this is the part that we want to integrate. So we have this part x over square root of 2x plus 1. Okay, so after that, we want to make x over square root of 2x plus 1 to be the subject. Alright, so I have to move this to the right hand side, right? This fraction to the right hand side when it becomes plus 2 over square root of 2x plus 1. So the rest I just copy down. And this 3, I will take it out so that I can see this is the part that I want to integrate clearly. Okay, so the next step, I can start to integrate for both sides. So the left hand side is 3 integration from 0 to 4 x over square root of 2x plus 1 dx. Then the right hand side integration from 0 to 4, then everything from the right hand side and with dx. Alright, so now I can start to integrate this part. Okay, so when I integrate differentiation of this whole thing, right, it will be still remain with this whole thing. And to integrate this part, right, so all this will be copied down the same, but the power I will have the plus 1, so negative half plus 1 is half. After that, I differentiate the bracket 2x plus 1. When I differentiate 2x plus 1, I get 2. So I will write down at the bottom 2 here. Okay, now from here I simplify. For this part, right, it becomes 2 square root of 2x plus 1. So the rest pretty much is similar. Just copy down and take note that the 3 over here, I move to the right hand side. It becomes 1 over 3. So now the left hand side only is the part that we are interested in. Integration was 0 to 4 x over square root of 2x plus 1 dx. Okay, so the next step is we can start to substitute the 4 inside the whole thing. Then minus 0, substitute 0 into the whole thing. So substitute 4 inside everything here. This is what I get. 4 minus 3 times square root of 2 times 4 plus 1 plus 2 square root of 2 times 4 plus 1. Then minus, substitute 0 inside the whole thing. We have 0 minus 3 square root of 2 times 0 plus 1 plus 2 times square root of 2 times 0 plus 1. So calculate everything here. We'll have 1/3 times 3 plus 6 minus bracket negative 3 plus 2. Okay, and press calculator, we get 10 over 3 or 3 and 1/3. Question 9. The equation of a circle is x squared plus y squared minus 16x minus 2y plus 40 equals 0. A. Find the radius and coordinates of the center of the circle. 4 marks. Okay, so to find the coordinates and the radius of the circle, first, given this equation, we rearrange this equation so that the x squared term is with the x term, the y squared term is with the y term. So I want to do this. The next step we want to do is we perform completing the square. So x squared minus 16x, when I perform the completing the square, it becomes x minus 8 square minus 8 square. Do the similar thing for the y square and the y term here. So we'll get y minus 1 square minus 1 square. and plus 40 just copy down, then equals to 0. So the next step is simplify everything here, right? We'll have x minus 8 square minus 64 plus y minus 1 square minus 1 plus 40 equal to 0. Okay, simplify further, x minus 8 square plus y minus 1 square equals 25. So the 25 is 5 square, so which means that the radius is 5 and the coordinates of the center is 8, 1. Okay, this come from here, the 8 come from here, the 1 come from here. B. Find the shortest distance of the center of the circle from the line y equals 2x and explain why the circle does not intersect the line y equals 2x. So 5 marks. Alright, to illustrate the case here, right? So let's draw a line, a straight line. Equation is y equals to 2x. So let's say this is the center of the circle, coordinates is 8, 1. Okay, so I want to find the shortest distance, which means the perpendicular distance from the center of the circle to the line. Okay, so I label this line as D. Now, this point is the point where it is perpendicular to the center of the circle. Okay, and the coordinates of this point will be A to A, because based on the equation y equals to 2x, when x is A, then the y is 2A. So from here, the gradient of D is negative half. Okay, why is it so? Because the gradient of this straight line is 2. So D is perpendicular to this line. Hence, the gradient of D is negative half. Remember, if two lines are perpendicular to each other, when we multiply their gradients, will give us negative 1. Okay, so from here, we already know the gradient of the line D, and we know the coordinates of this point. Then we can form the equation of the line D, which is y minus 1 equals negative half x minus 8. So make y the subject, we have y equals negative half x plus 5. So this is the equation of the line D. And from here, right, when x is a, y is 2a, then we can find the coordinates of this point, or the value of the a here, right? Substitute inside this equation, we have 2a equals negative half a plus 5. So 5 over 2a equals 5, so a will be 2. In other words, the coordinates of this point will be 2, negative 4. Okay, so this is not what we want. We want to find the shortest distance. In other words, we want to find the distance of this line. So from here, the shortest distance will be square root of. We use the coordinates of this point and this point to find the shortest distance. It will be square root of 8 minus 2 square plus y minus 4 square. Then calculate, we have square root of 45, or in third form, 3/5 units. Okay, now when you press calculator, we know this value is 6.71 units rounded out 3 SF. So why we want to do this? So that we can compare this length with the radius. Okay, from here we can see that the shortest distance is greater than radius. So this tells us that the circle does not intersect the line. So if the circle intersects the line, then the shortest distance should be less than the radius. The point C, 11, 5, lies on a circle and CD is the diameter of the circle. C. Find the coordinates of D. 2 marks. So to illustrate this case, let's draw a circle with the center O with the coordinates of 8, 1. So this is the diameter of the circle. This point is point C with the coordinates of 11, 5. So this point is point D, and let's label the coordinates of D as P, Q. So as you can see from this diagram, O is the center of C and D. Hence, we can apply the midpoint formula. So 0, 8, 1 equals P plus 11 over 2, Q plus 5 over 2. Then we compare the x coordinates. 8 equals P plus 11 over 2. We solve this equation. P plus 11 equals 16 and P equals to 5. Then we compare the y coordinates. 1 equals q plus 5 over 2. Q plus 5 equals 2, hence q equals -3. Therefore, the coordinates of D is 5, -3. Question 10. Given this diagram, the diagram shows part of the curve y equals 9 over 3 minus 2x and the tangent to the curve at the point P, -3, 1. The curve intersects the y-axis at A and the tangent intersects the y-axis at B. A. Determine with working whether B is nearer to O or to A. 6 marks. Okay, so to determine whether B is nearer to O or A, the first thing we have to do is we need to find the coordinates of point A and point B. So to find the coordinates of point A, we can use the equation of the curve y equals 9 over 3 minus 2x. Okay, and since A lies on the y-axis, then we can let x to be 0. Substitute inside this equation. So y equals 9 over 3 minus 2 times 0, the y equals to 3. Therefore, the coordinates of A is 0, 3. So let's label it on the diagram. The point A is 0, 3 here. Next, to determine the coordinates of point B, the first thing we have to do is we need to find the equation of the tangent. And to find the equation of the tangent, first we need to know the gradient of the tangent. Okay, and we already know the coordinates of point P, then we can form the equation of the tangent. Alright, so to find the gradient of the tangent, first we rewrite the equation of the curve y equals to 9 times 3 minus 2x to the power -1 so that we can differentiate this y easily. So dy over dx will be -9 times 3 minus 2x to the power -2 times -2, which we get 18 over 3 minus 2x squared. Alright, so to find the gradient of the tangent, we let x equal to -3 because it is a point P here. So the dy dx will be 18 over 3 minus 2 times -3 square, and the value is 2 over 9. Okay, so now we know the gradient of the tangent and we know the coordinates of point P, -3, 1. We can form the equation of the tangent. So now y minus 1 equals 2 over 9 times x plus 3. Rearrange this equation to make y to be the subject. Y equals 2 over 9x then plus 5 over 3. Okay, so the B is the y-intercept of the straight line. Hence, this will be the y-coordinates of point B. Hence, the coordinates of B will be 0, 5 over 3. So let's label this as 0, 5 over 3. Okay, so we know the coordinates of A and B. Now we can answer the question. So is B nearer to O or to A? So let's see, right? The distance of AB will be 3 minus 5 over 3, which we get 4 over 3. The distance from B to A, B to O, or OB is 5 over 3. So we can see that AB is less than OB. Therefore, B is nearer to A. Question B. Find, showing all necessary working, the value of the constants A and B, for which the area of the shaded region can be expressed as A ln 3 plus B. 6 marks. So to find the area of the shaded region, first we need to find the area under graph here. So let's label this area under the graph as A1. So A1 will be integration from -3, 0, 9 over 3 minus 2x dx. So when we integrate it, we get -9 over 2 ln 3 minus 2x from -3, 0. So we can take out the constant -9 over 2 so that we can calculate the integration easier. After that, we substitute 0 into the expression, then minus -3, substitute -3 into the expression, we get -9 over 2 ln 3 minus ln 9. Or we rearrange the expression, then we get 9 over 2 bracket ln 9 minus ln 3. So since minus in logarithm means it's division, so it's ln 9 over 3 and we get ln 3. So simplify, we get A1 is 9 over 2 ln 3 units. Next, we want to find the area of this trapezium. So let's label this area as A2. So the area of this trapezium A2 will be half times 1 plus 5 over 3 times 3. So this is the formula to find the area of a trapezium. Then we calculate, we get 4 units square. Alright, now we can find the area of the shaded region now, where the area of shaded region will be A1 minus A2. So substitute the value here, 9 over 2 ln 3 minus 4. So compare the one that is given, hence we can see that A is equal to 9 over 2, B equals to negative 4. Alright, that's the end of the paper, and that's all for this video. Thanks for watching. Do you have any question or doubts to ask? Feel free to write it down in the comment. I would love to hear from you. Do you like this video? Please don't forget to like it and share it with your friends. Until then, see you in the next video. Have a great day ahead and all the best.